Hello students and viewers at home. My name is Dr. Mrs. Ezeama from Mathematics Department, St. Charles College, Onitsha. You are all welcome to our online teaching. My subject today is mathematics and the topic is statistics, precisely measures of central tendency of ungrouped data. Let us look at specific objective for the topic. By the end of the lesson, the students should be able to define statistics. To say the meaning of the following measures of central tendency: mean, median, and the mode. Then we'll be able to solve problems involving mean, median, and the mode. Let us look at definition of statistics. Statistics is the science of collecting, organizing, and analyzing data for any given purpose. Example, measures of central tendency. Measures of central tendency or measures of central location. The two are the same thing. Either you call it measures of central tendency or measures of central location. The mean, median, and mode are called measures of central tendency or measures of central location because they describe the center or middle element of a set of data. We are going to discuss them one by one. Mean. Mean is the sum of a group of items divided by the number of that group or number of items involved. Mathematically, mean is equal to the sum of items all over sum of items. Mean is sum of items over number of items. Summation n over n. That sign is summation, and n is the number of times of that items. Note, the meaning here is arithmetic because the figures involved do not occur so many times. Find the mean. Let us look at the examples. Examples of mean. Find the mean of the following set of numbers. I will call the questions, then we go over to the solutions. 1, 3 and 7. 2, 0, 1, 16. 3, 21. 8, 1 and 6. 4, 7, 3, 3, 7, 1 and 7. 5, 1.3, 0.7, 2.6, 1.4, 0.5, and 0. Let us now look at the solutions. In the case of 1, 3 and 7, you know we have 3, one number, 2. Now, you are going to, because there are two numbers, you now divide with 2. So 3 plus 7 all over 2 is equal to 10 over 2, which is 5. And that 5 is our mean, which is the answer. 2. You sum up the numerator. 0.2, 0 plus 2 plus 16 all over 3 is equal to 18 over 3. When you divide 18 by 3, you get 6, which is the answer. Number 3, 21 plus 8 plus 1 plus 6 all over 4, which gives us 36 over 4, which is 9, and 9 is the answer. Number 4, 7 plus 3 plus 3 plus 7 plus 1 plus 7 all over 6. That gives us 28 over 6. And if you divide 28 by 6, you get 4 whole number, 2 over 3, which is the answer. In number 5, 1.3 plus 0 plus 0.7 plus 2.6 plus 1.4 plus 5.5 plus 0. 0 is, remember, 0 is their number. Divided by 6, since there are 6 in number. Now we get 6.5 all over 6, which is equal to 65 over 60. How? You want to change that decimal to whole number. You multiply 6.5 by 10. Then whatever you do to the numerator, do so to the denominator. Now, when you multiply 6.5 by 10, you get 65. And 6 times 10, you get 60. 65 divided by 6 will give you one whole number, 1 over 12. Example 2. Most of the time, the mean will be given, and you will be asked to find the missing item. Example, if the mean of 5 observations is 15, and the 4 of them are 11, 12, 19, 20, what is the 5th item? Solution is, first of all, assume the 5th position to be x. The mean is total score of the observation over number of scores, which means now make that 15 the subject of the formula. Then 15 is equals to 11 plus 12 plus 19 plus 20 plus x all over 5. You make 15 to be in fraction so that you will be able to cross multiply. 15 over 1 is equal to 62 plus x all over 5. Here you have two ways of solving it. Either you multiply both sides by 5 or you cross multiply. Whichever one you take, you will get the same answer. So if you collect the like terms now, you will get x to be equal to 75 minus 62. Therefore, x is 13, which is the answer. The mean, question number 2, the mean of 9, x and 13 is 11. Find now the value of that x. Solution is summation n over n. Now we make 11 the subject of the formula. 11 is equal to now 9 plus x plus 13 all over 3. Now let it be in a way you can cross multiply. 11 over 1 is equal to x plus 22 all over 3. If you cross multiply, you get the answer as 3 multiplying 11 to give you 33. X plus 22 is equal to 33. You collect like terms. The like terms are 3 and the 22. So x is equal to 33 minus 22. Therefore, x is equal to 11, which is the answer. Let us look at the median, one of the measures of central tendency. The median of a set of items arranged in order of size is the middle item if the number of items is odd. Hence, when the items are even, the mean of the two middle items becomes the median. Median divides the data into two equal parts. Note, if raw data are given to, no matter odd or even, first arrange the data in order, either in ascending or descending order. Examples. Let us look at this problem when the data is odd. Find the median of the following set of numbers. 1, 2, 8, 0, 6, 2, 3, 9, 4. 8, that is number 2 now. 8, 1, 10, 3, 10, 2 and 5. Number 3, 65, 72, 55, 48, 78. Number 4, minus 2, 0, minus 3, 7, 1, 2, 10. Number 5, 0.6, 2.2, 1.5, minus 9.3, and the 9. These are the questions we are going to apply the solution now. First, let us arrange in ascending order. 0, 1, 2, 2, 3, 4, 6, 8, and the 9. If you look at this, you see that the middle number there is 3. Answer now is 3 because 3 is the middle value. You can now say 1, 2, 2, 4. For this side, for this side. See that 3 is in between. Number 2, 0, 1, 1, 2, 5, 8, and 10. Then the median is 2. 3, 48, 55, 65, 72, and 78. The median there is 65. Number 4, if you look at minus 3 and minus 2, see that we are following the number line. The number line after 0, by the left hand side, you can see minus 1, minus 2, and minus 3. So minus 2 is greater than minus 3. That is why, as we are arranging in ascending order, minus 3 comes before minus 2, then we get 0, 1, 2, 7, and 10. See that now the median is 1. In number 5, no matter the size of the number there, 9.3 minus is there, so it is the smallest. Now we get minus 9.3, 0.6, 1.5, 2.2, and the 9. The median there is 1.5, which is the answer. Let us look at when median is even number. Find the median of the following. Now the median here is 2, 4, 1, 3, 6, and 7. You now find the two middle numbers in between this set of numbers. See that you will first of all arrange. You are now rearranging in descending order. If you first of all arrange, you see that we now have 7, 6, 4, 3, 2, and 1. You see the two middle numbers there, 4 and 3. You now sum them up and divide by 2. That is how we get 7 over 2. And the answer is now 3 whole number, 1 over 2, or 3.5. Number 2 of the solutions, 18, 15, 12, 11, 9, 7, 6, and 5. The median there is 11 plus 9 all over 2, which is 20 over 2, which gives us 10, the answer. Number 3, 12.2, 9.4, 8.6, 8.4, 7.8, and 2.5. The median there is 8.6 plus 8.4. If you sum them up, you get 17 over 2, which gives us 8.5 as the answer. Number 4, 8.5, 6, 4, 0, minus 1.5, and minus 7. The middle numbers there are 4 and 0. 4 plus 0 over 2 gives us 2, because 4 plus 0 is 4, And when you divide 4 by 2, you get a 2. Number 5. 53, 48, 32, and 27. Remember, we are going on as descending order, not ascending now, from big to small. The first one we did from small to biggest. But in this case, you see 53, 48, 32, and 27. We are now descending. Now 48 plus 32 over 2 is 80 over 2. And when you divide 80 by 2, you get 40, which is the answer. Let us now look at the mode. The mode of a set of number is that value which you call most. It is the most common value. The mode may not exist, or it may not be unique when we have more than one mode. Examples. Find the mode of the following set of numbers: 2, 3, 5, 7, 10, 8, 12, 8, and 9. Number 2, 1, 2, 4, 4, 3, 4, 7, 9, 7, and 7. Number 3, 2, 3, 4, 5, 7, 9, 8. The solution. Look at the solution. Mode here in number 1. If you look at the set of numbers there, you see that 8 appears twice, while others appears only one. Now, 8 is the mode because 8 occurs more than other numbers in the set. Number 2, we have bimodal. When you have two numbers that are greater than others, you have bimodal. Here, mode is 4 and 7. Because if you look at number 2, you see that 4 appears 3 times, 3 appears 2 times, but 7 appears 3 times again. 1 is only once, 2 is only 1, and 4 1. So we have 4 that have 3 chances there. 7 have 3 chances. That is why we have 3 bimodal, which is 4 and 7. Number 3, mode does not exist. Because if you look at number 3, you see we have 2, 3, 4, 5, 7, and 9 and 8. No number there appear twice. So there is no mode. That the answer is mode does not exist. You can find many of them in many textbooks, and you'll be able to solve them like the ones I've given you here. Let us look at evaluation. Define statistics. Say the meaning of the following: measures of central tendency, mean, median, and the mode. Number 3, find the mean of the following exercises: 1, 21, 8, 1, 6. Number 2, 5, 8, 3, 7, 1, and 4. Number 3, 1.5, 0.7, 2.6, 1.4, 0.5, 0.6. B part of it says the mean of x, 3, bracket, s minus 1, 5, and 2s minus 2 in bracket is 5. Find the value of x. Number 4. Find, correct to 2 decimal places, the mean of 0.9, 13, 16, 1.7, 19, 23, and 24.35. Number 5. Find the mean of the first prime numbers greater than 10. Remember, you will remember that you know the first prime number. What is the prime number? Before you'll be able to find those that are greater than 10. Number 6. Find the median of the following: 4, 5, 6, and 3. 3.5, 1.5, 7.2, 5, and 6. Number 3. 9, 17, 0, 33, and 24. Number 4. 52, 75, 39, and 42. Number 5. 0.81, 0, 39, 3.8, and 4.2. In this case, remember to arrange in ascending or descending order, because these are in raw data. Number 7. Find the mode of the set of numbers. Number 1. 10, 9, 9, 10, 8, 11, 8, 10, 9, 8, and 14. Number 2. 2, 3, 6, 3, 2, 4, 3, 3, and 5. Number 3. 8, 2, 5, 2, and 7. You are going to solve all these numbers and send to my WhatsApp number 080 608 71316. I repeat, 080 608 71316. Thank you for listening. Stay safe.